Right, good morning, student. Today we're going to delve into part of the solution chemistry. Today we're looking at molarity, and we're going to look at how do we dilute solutions in the lab, and then do some interactive discussions. Welcome on board.
Refers to the concentration of species in solution. The species is called the solute. The solute dissolves in a liquid called the solvent. Hence, a solution is composed of solute and solvent. Qualitatively, a dilute solution has a low concentration of solute, and a concentrated solution has a high concentration of solute. The terms dilute and concentrated are used in a comparative sense. In commercially available solutions, like concentrated HCl or concentrated H2SO4, the term concentrated refers to the maximum concentration of that solution available. Always use extreme caution in handling concentrated chemicals. Molarity is the unit of concentration, or the amount of solute in a solution. The amount of solute refers to the moles of solute. Molarity, M, is equal to moles of solute N divided by liters of solution L.
Remember, mole is equal to mass divided by molar mass.
Or molarity, M, is equal to mass in grams divided by molar mass in grams per mole times liters of solution L. Thus, mass in grams is equal to molarity M times molar mass in grams per mole times liters of solution L. The molarity M of a solution can be used to calculate A, the amount of solute, moles, or mass in a given volume of solution, and B, the volume of solution containing a given amount, moles, of solute.
This is very important for you to remember. These are some of the formulas that you will not be given in the exams. It's not part of the formula sheet. You not see this, so you have to know exactly how to find the molarity. Then the mass, the molar mass of the substance, and the liters of solution. These are very important concepts because you're going to know how to make a solution in the lab. Unfortunately, we are not in the lab physically, so we can't really do hands-on. So you have to practice this using these calculations.
Example, calculate the mass of KMnO4 needed to prepare 700 milliliters of 0.583 molar solution of KMnO4. To calculate the mass of KMnO4, use the second equation. In the example, molarity is given. Calculate the molar mass of KMnO4. Molar mass equals is equal to 158.0 grams per mole. Convert 700 milliliters to liters. 1,000 milliliters equals 1 liter. Hence, 700 milliliters times 1 liter divided by 1,000 milliliters equals 0.7 liters, equals 64.5 grams. Therefore, 64.5 grams of KMnO4 dissolved in 700 milliliters of water produces 0.583 molar solution of KMnO4. Example: calculate the volume in milliliters of 0.215 molar H2SO4 solution containing 0.948 grams H2SO4.
All right, let's try this. Let's see how we can handle this using the formula. So manipulate the formula and see what you are given and what you need to know. Let's pause this and then work it out on our own.
Rearrange the first equation to calculate for volume. Liters of solution L is equal to mass in grams divided by molar mass in grams per mole times molarity M. The mass of H2SO4 is given. The molarity of H2SO4 is given. Calculate the molar mass of H2SO4. Molar mass equals 98.1 grams per mole equals 0.0449 liters. However, the example asks to calculate the volume in milliliters. 1,000 milliliters equals 1 liter. Hence, 0.0449 liters times 1,000 milliliters divided by 1 liter equals 44.9 milliliters. Example: a 75 milliliter solution of AgNO3 contains 0.0385 moles of AgNO3. Calculate the molarity of the solution.
Right, let's figure this out first before we look at the solutions.
The above equation can be written as molarity M equals moles of solute N divided by liters of solution L equals 0.0385 moles divided by, convert 75 milliliters to liters. 1,000 milliliters equals 1 liter. Hence, 75 milliliters times 1 liter divided by 1,000 milliliters is equal to 0.075 liters, is equal to 0.513 molar. Example: 23.0 grams of NaOH is dissolved in 1.5 liters of water. Calculate the molarity of the solution. Remember.
All right, this is question 1. I want you to take your pen and pencil You're going to work this out on your own and then submit your response into the Google Classroom. I'll try to copy the question as well and put it in Google Classroom. That's question 1.
Calculate the number of grams of K2HPO4 needed to prepare 0.35 liter.
Next question 2.
The amount of solute is given in moles. Calculate the volume of 0.5 molar.
This is question 3.
Sodium carbonate dissolves in water to give Na plus and CO3 2- ion.
Right, let's look at molarity of ions in an ionic solution.
Aqueous solutions of salts conduct electricity, showing that salts break into ions in solution.
Salts break down into cations and anions. The ratio of cations and anions produced is given by the ion's chemical formula.
Polyatomic ions remain intact as ions in solution. For example, sodium sulfate dissolved in water breaks down into Na plus aqueous and SO4 minus 2 aqueous ions. SO4 minus 2 is a polyatomic ion.
From the chemical formula Na2SO4, the ratio of ions in solution is 2 Na plus aqueous plus SO4 minus 2 aqueous.
Consider an aqueous solution of 1 molar NaCl. In solution, NaCl breaks down as Na plus aqueous plus Cl minus aqueous. Hence, in 1 molar NaCl solution, the concentration of Na plus aqueous equals 1 molar, and Cl minus aqueous equals 1 molar.
Now, consider a 1 molar aqueous solution of Na3PO4. In solution, Na3PO4 breaks down into 3 Na plus aqueous plus PO4 minus 3 aqueous. Hence, in 1 molar Na3PO4 solution, the concentration of Na plus aqueous is 3 molar, and PO4 minus 3 aqueous is equal to 1 molar.
This is very important when you break down the ions. Number of moles determine the amount of concentration of that ions in the solution.
Thus, an ionic solution contains a mixture of ions, each with its own molarity.
Example: calculate the molarity of ionic species present in 250 milliliters of an aqueous solution containing 1.85 grams of ammonium sulfate. Remember,
Molarity M is equal to mass in grams divided by molar mass in grams per mole times liters of solution
equals 1.85 grams divided by the chemical formula of ammonium sulfate is parentheses NH4 twice SO4. Molar mass equals (132.1 grams per mole).
Convert 250 milliliters to liters. 250 milliliters equals 0.25 liters.
Equals 0.056 molar.
Hence, the concentration of NH4,2SO4 is 0.056 molar.
In solution, NH4,2SO4 breaks down as. Thus, the concentration of NH4 plus aqueous equals 2 times 0.056 equals 0.11 molar, and the concentration of SO4 minus 2 aqueous equals 0.056 molar.
I hope you are taking down notes. This is very important. They are systematic.
Example. Calculate the molarity of ionic species present in 0.50 liters of an aqueous solution containing 1.50 grams of calcium hydroxide.
All right, this is problem number 4, which I'm going to submit. That's question number 4.
The molarity of ionic species present in 0.25 liters of an aqueous solution can.
This is question number 5.
Molarity, M, is equal to mass.
Commercially available concentrated solutions are often called stock solutions. For example, commercially available concentrated HCl is usually a 12.0 molar solution. The question is how to prepare 100 milliliters of 1.0 molar HCl solution from 12.0 molar HCl solution.
This is how to dilute concentrated solution in the lab. Now, this is a very powerful, very strong solution in the lab, 12 molar. Normally, I don't bring this type of concentration or concentrated solution out to students. This is always in the stock room. It's under lock and key because it's very, very dangerous. It is 12 molar solution, very powerful, very strong. So we call it stock solution. This is the way we bought it from the manufacturer. It was usually in the powder form, so they make it in the concentrated solution for us, and they now ship it. And this is the situation where you have it in the lab. So what you have to do now is to dilute it to the specification that we want in the lab. For instance, the question is how to prepare just 100 ml of 1 molar solution from 12 molar. Now, what does that mean? Let me tell you a little bit about this. HCl has molar mass of 1 plus 35.5. The total is 36.5 grams per mole. So, if you want to prepare 1 molar solution, what you do is to dissolve 36.5 grams of this solution in 1 liter. That will give you 1 molar solution. So 36 grams, 36.5 grams dissolved in 1 liter will give you 1 molar solution. So how did they get this 12 molar solution? That means they dissolve 36.5 times 12. 36.5 times 12 will give us 438 grams. So this was dissolved in just 1 liter. You see how powerful it is now? 36.5 grams dissolved in 1 liter will give us 1 molar solution. To get 12 molar solution, you dissolve 36.5 times 12. That means 438 grams of that powder in the same 1 liter solution. You see how powerful it is? That is what you call stock solution. Okay?
The obvious answer is dilute the concentrated HCl, that is 12.0 molar HCl. But what volume of 12.0 molar HCl should be diluted? To obtain this value, recall the definition of molarity.
Molarity, M, is equal to moles of solute, N, divided by liters of solution, L.
Hence, moles of solute, N, equals molarity, M, times liters of solution, L. This equation can be written as moles of solute, N, equals Mi times Vi. The subscript I stands for initial. Thus, Mi equals initial molarity, and Vi equals initial volume. Now, add water to the solute. This changes concentration and volume. Thus, moles of solute N equals MF times VF. The subscript F stands for final. Hence, MF equals final molarity and VF equals final volume. Because moles of solute has not changed during dilution, Mi times Bi equals Mf times Vf. Mi equals 12.0 molar. Vi is to be calculated. Mf equals 1.0 molar. Vf equals 100 milliliters. Equals 8.33 milliliters. Use any volume units as long as Vi and Vf have the same units. Take a clean 100 milliliter volumetric flask, add approximately 25 milliliters distilled water, then carefully and slowly add 8.3 milliliters 12.0 molar HCl solution. Remember, always add acid to water very slowly. Add more water to bring the total volume to 100 milliliters. Example: a stock solution of 15.8 molar HNO3 is given. How many milliliters of the stock solution are required to make 0.250 liters of 0.12 molar HNO3?
All right, let's ponder over this.
Mi times Bi equals Mf times Vf. Mi equals 15.8 molar. Vi is to be calculated. MF equals 0.12 molar. VF equals 0. Equals 0.0019 liters. 0.0019 liters times 1,000 milliliters divided by 1 liter equals 1.9 milliliters. Example: a stock solution of 18 molar H2SO4 is given. How many milliliters of the stock solution are required to make 0.10 liters of 0.22 molar H2SO4?
Right, this is your question number 6.
Liters of 0.50 molar acetic acid solution can be formed from 0.30 liters of 2.0 molar acetic acid solution.
Question number 7. All right, so we're going to stop here today. Make sure you complete those interactive questions and turn them into the Google Classroom. Thank you.